So basically in this question, the width is given to you 250 mm. The span is also given, that is 6 meters. And the grade of concrete and steel is given to you. And the UDL is given to you. UDL is 40 kilonewton per meter. And it is including with the self weight. So basically this is given to you. And you have to find out what you have to find out the effective depth and the steel. So if this is given to you, that means what is known to you, M20 means what is sigma CBC and sigma ST is given to you basically. So from this you will get the value of sigma CBC. What is sigma CBC? For M20 grade of concrete, sigma CBC is 7, and for Fe415, sigma ST is 230. Okay. So basically these things are given to you. So the first step is to find out the critical neutral axis from the equation sigma CBC upon sigma ST by M XC upon B minus X. So in this M also you have to find out, M is given by 280 upon 3 sigma CBC. Sigma CBC is 7. So this is 13.33. So from this you will get the value of XC in terms of D. So 0. Let us say 29D. Next step is to find MR. So MR is given by C into Z, which is B into XC into sigma CBC by 2 into D minus XC by 3. So this you will get in terms of B and D. So can anyone tell me what you're getting MR in terms of B and D? Just write in the chat box. I hope I'm audible to everyone. Please write in the chat box what you're getting MR in terms of B and D. Since B is given to you, so you will get only in terms of D. Yes, Avinash, you can directly write in the chat box for everyone to see. 0.91 BD square. The value of B is given to you, Rita. So you can substitute that and give me the value of in terms of only D. See, the value of B is 250 M. Okay. To 36.25 D square, 229.25 D square, 229.25 D square. So now we have to equate. The next step is equate MR to M. But for that we need the value of M. Do we have the value of M? We have to find out. Okay. So where M is equal to, we have been given the data. The span is 6 meters and the UDL on the beam is 40 kilonewton per meter. So can you find out the bending moment? Yes. So M is given by WL square by A. So give me the value of this, where W is 40. So give me the value of bending moment. See, we have already solved the first problem, so you have to be a bit quick now. 180, correct. We have to solve a lot of problems in design. So be quick as you are in the class. Consider this as a class, solve accordingly. So your bending moment time is 180. So now you can equate MR to M. So therefore 180. So remember the units when you're finding out the depth in mm. So you have to put the value of bending moment also in mm. So this is equal to 229.25 d square, which implies d is equal to how much? 886.33. Correct. 886.33 mm. Others, just check. Are you getting 886 or any other value? Let me know. So now you got only the effective depth. Okay, so you have to find out the overall depth. So for that, you need to consider a suitable cover. So let us assume, considering effective cover. So let us directly assume the effective cover as 50 mm. Okay, so remember one thing in design problem, you can directly consider the effective cover on a bit higher side, that is 50 mm. So it will take care of the layers, whatever you're going to provide. So it is always better, you can take it as 50 mm. So therefore, overall depth D will become 886.33 plus 50 mm. So give me the value of overall depth D. How much you're getting? 886.33 plus 50. So just be with me whenever I'm solving. So you have to give me the values. 936.33, correct? So this is 936.33 mm. So as I've already told you, we don't keep the depth of the beam in decimal form like this. So we will approximate it to a suitable value. So therefore, provide overall depth D is equal to 950 m. Okay. So as I've already told you, so you can keep in multiples of 50 the overall depth. So let us keep the overall depth D is equal to 950 mm, or you can also consider 940 mm. There is no problem in that. Okay. So as I told you, in design nothing is wrong. So it depends upon your assumption and your approximation. So even though if you keep it as 940, no one will say that it is wrong. Okay. So let us say that D is equal to 950. So therefore now you have to find out the effective depth. That is small d. This will be given by how much? The overall depth minus the effective cover. Okay. So this will become 900 mm. Is that fine? Yes, am I audible, everyone? Yes, Hamza, do you want to say something? So you got the dimensions. So we got the value of B also and D also, right? So B is already given to you. So therefore, B is 250 mm and D is 900 mm. So now find out the steel. Give me the value of steel now. With this data, so those who can refer, they can just write down this or they can solve on their own. Anyone got the value of steel? Okay, so AST Zainab has got 958. Rohit 962. Okay, so you have to give me the right answer. So the next step is find AST. So by equating C equal to T, let's say B into XC into sigma CBC by 2 into T is nothing but sigma ST into AST. So B is nothing but 250. XC is nothing but 0.29 D, where D is small d is I think 900, and sigma CBC is 7, and sigma ST is 230 into AST. So this will give you the value of AST 958.69. Is that correct? All of you getting the same value? 958.69. Anyone who is not getting this value? Okay, you have to give me the value. I don't have the value of AST. So I hope this is the right value. 986. Always has got 986. Yes, what happened, Mohit? What is your question? To find out the AST, we are equating C equal to T as we have done in the previous problem. You can just check the previous problem. For finding out the AST, you can equate C equal to T, or you can find out by MR is equal to T into lever arm. Okay, so let us check by MR is equal to T into Z, what you're getting. We got the value of MR 180. This is sigma ST into AST into D minus XC by 3. Okay. Yes, Samir 992 with this. So with this equation, what is the value you are getting? Okay, so sigma ST is 230, AST is the unknown, and D is 900, small d is 900, and XC is 0.29D. Okay, 0.29 into 900 by 3. So this will give you the value of AST. Yes, everyone getting this 992, same value. Yes, is it 992 for MR is equal to T into Z? Then what is the value? Yes, Danish, you want to say something? Okay, 962.
ये मिल गया giving A1 A2 direct flow level.
Okay, for C equal to T, Samir is saying it is 992. Is that correct, everyone?
सर को तो इतना है बाहर जाएगा तो बात नहीं हो जाएगा हाँ हाँ हो जाएगा मामा बाहर जाएगा तो पर
Yes, please mute yourself, Danish. Yes, so now after this, select a suitable diameter. So let us assume diameter 20 mm diameter bars. So therefore, number of bars find out. So let us select this 962. So what are the number of bars? Yes, all of you getting this 992. Who said 958? Is it the right, this value or this you're getting? Okay, so Mohit. Okay, fine. So because of that decimal change, the value is differing. So accordingly, you can select. So no problem with that. So even in design problem, if you change the decimal, with that also there is a huge change in the answer. So please take care of that. So you can approximate it to 3 digits or 2 digits. So now for this, what is the number of bars? 3.06. Okay. So if you take 20 mm diameter bar, so it is slightly greater than 3. So if you take it as 4, so that will be more steel. Any alternative for this anyone can say? No, Samir, we cannot provide. So remember one thing, whenever you are getting this value, this is your AST required. So remember one thing, whenever you are providing AST provided, that AST provided should not be less than this. It should not even be 961. So remember this, whenever you are providing the steel, it should not be less than the AST required. So you have to take care of that. So any alternative? So if you are providing 4 bars of 20, so it will be, I think, 1256, which will be much higher. Change the dia. Okay, which diameter are you suggesting, Abrar? 16 mm. So give me the value for 16 mm diameter. How many bars you are getting?
Excuse me, sir.
Yes.
Hello.
Yes.
Yes, sir. The equation to T to Z, T into Z.
Right.
So the second equation to find IST. So, sir, 180 into 10 raised to 6 is the value of M. MR is
Yes. So the bending moment which is
25
acting,
D.
the bending moment which is acting for that, you have to find out the steel. Remember, what is the acting
Oh,
moment given in the
okay, sir.
question? Okay. The acting moment, to resist that acting moment, we are providing the steel.
Okay, okay, sir. Thank you, sir.
So for 16 how many bars are coming? 5 bars, 4.78. So either you can provide 5 bars of 16. Okay. So 5 bars of 16. What is the AST provided? Anyone? AST provided कितना आ रहा है? 5 bars of 16 में. First was 4 bars of 20 if I consider. So it is almost 1256.63 something. Okay, 1005.3. 1005.3 for 5 bars of 16. Okay, that will be fine. And can anyone tell me what is 220 plus 216? 220 plus 216. ये कितना आता है? Just give me the value of, if I use 2 bars of 20 mm diameter and 2 bars of 16 mm diameter. So what is the AST provided you're getting? $1030. Fine. ठीक है, तो ये भी तुम्हारे पास एक ऑप्शन है. ठीक है, you can provide 220 and 216 also, or you can provide 516 also. ये थोड़ा सा अनइकोनॉमिकल हो जाएगा. If you provide 4 bars of 20, तो अपना सिर्फ 962 रिक्वायरमेंट है, तो ये अनइकोनॉमिक थोड़ा हायर साइड पे हो जाएगा. ठीक है, so generally we provide economical section. So उसके लिए either you can go for 516 or 220. As I've already told you, there is nothing wrong or right in design problem. तो which is most appropriate वो हमको select करना है. मैंने 5 bars of 16 मैंने दिया, तो 3 नीचे आएगा और 2 second layer में आएगा, correct? और 2 bars of 20 और 216 मैंने दिया, तो 2 नीचे और 2 ऊपर रहेंगे. So less congested कौन सा रहेगा इसमें से? तो ये रहेगा less congested. Are you getting? So you can say this is the most preferred reinforcement or combination of reinforcement. Understood, everyone? So now let us draw the reinforcement detailing for this. So that is the reason I just explained you. Okay, you can provide reinforcement in any of these things. Nothing of this combination is wrong. Neither of this combination is wrong. Okay. See, generally for longitudinal reinforcement, we don't consider 8 mm diameter. Arman Chauhan. Okay. So 8 mm diameter generally we use for stirrups. So for longitudinal reinforcement, you start with 12 mm dia. Okay. So generally, the diameters which are available in the market, it starts with, actually in Mumbai में तो 6 से start नहीं होता है, फिर भी theoretically I'm starting with 6. फिर उसके बाद है 8, फिर 10, फिर 12, फिर 16 है, फिर 20, then 25, then 32. ठीक है, फिर 40 भी है, जो बीम में ज़्यादा यूज नहीं होता है. So these are the dimensions of the bar which are normally used on site. Okay, so after 8 mm, in some textbooks you will find 22 mm. So actually is ज़्यादा use नहीं होता है site पे. 22 mm is not used. ठीक है, so 12 के बाद 16 है, 20 के बाद फिर directly we use 25 mm dia, then 32. Columns में 40 वगैरह use होता है. Okay, so I told you not to write the attendance in between when we are discussing the problem. Tanveer Khan. That means you have just joined the session. Am I audible, Tanveer Khan? Please unmute yourself, Tanveer. What I told, not to write the attendance in between the session when we are discussing the problem. Have you joined now? Yes or no? Have you joined now? Yes. So next time I will not consider whoever is writing in between the session. Okay, start right at the beginning or at the end. I will give you time. So the reinforcement detailing for this will be, so I think the width is 250 mm, correct? And so which arrangement are you preferring in this? So let us prefer this arrangement. Okay, 2 bars of 20 and 2 bars of 16. Why? Because in this less congestion is there. So in this we will have to provide 3 bars at the bottom and 2 bars at the top. Right? So just a matter of 25 mm square से कुछ फर्क नहीं पड़ेगा. So it is economical only. So 2 bars bottom, then the separator bar, then 2 bars. So remember, whenever you are providing two different diameter of the bar, so the higher diameter will be at the bottom and the lower diameter will be at the top. Is that clear? So this will be 20 dia and this will be 16 dia. So जो higher diameter है वो हमेशा नीचे रहेगा और जो lower diameter है वो second layer पे रहेगा. So what is the effective depth in this case? Will be from the center of the separator bar. What is the effective depth in our case? I think it is 900. And the overall depth it is 950 mm. Okay, so this is your reinforcement detailing. Okay, actually you can show the stirrups also. So when we design the shear reinforcement, at that time I will show. For the time being, you can consider this as a reinforcement detail. Okay, or if I want to show the stirrups, so it will be something like this. Okay, so this is called as the stirrup for the shear reinforcement, and these are your anchor bars. Okay, so the anchor bars are generally of 8 mm diameter or 6 mm diameter. So in Mumbai, generally we don't use 6 mm diameter. So in Mumbai, you can find the minimum diameter used is 8 mm. But in rural areas, you can find 6 mm diameter also. They still use 6 mm diameter. So the anchor bars are generally of 8 mm diameter. I hope this is clear to everyone. If anyone has any doubt in this, they can ask me right now. So please make a note of this reinforcement detailing. I want this at the end of every design problem. The reinforcement detailing should be there. So this shows that whether you have understood the design or not.